Hello everyone, welcome to the next session of Strength of Materials. In this session, we are discussing one last numerical on the topic of design of shaft. So let's get started. A hollow shaft of diameter ratio 3/8 internal diameter to outer diameter. So the data that is given to me is di by do is 3/8. I can also say that di is 3/8 times do is to transmit 375 kilowatt power. So the value of P is 375 kilowatt, that is 375 into 10 raised to 3 watt at 100 rpm. The value of N is 100 rpm. The maximum torque being 20% greater than the mean. So T max is 20% greater, that is 1.2 times T mean. The shear stress is not to exceed 60 Newton per mm square, that is tau max is given as 60 Newton per mm square, and twist in a length of 4 meter not to exceed 2 degree. So the value of theta maximum is given as 2 degree, that is 2 pi by 180 radian, and the length is given as 4 meter, that is 4000 mm. Calculate its external and internal diameter, which would satisfy both the above conditions. So I need to calculate di and do. Assume modulus of rigidity G as 0.85 into 10 raised to 5 Newton per mm square. So I'll write to find di and do by using both the criteria, that is strength and rigidity. First we'll start with P is equal to 2 pi n T mean upon 60. The value of P is given as 375 kilowatt and N is 100 rpm. So 375 into 10 raised to 3 is equal to 2 pi into 100 into T mean upon 60. When I solve this, I get the value of T mean as 35.809 into 10 raised to 3 Newton meter. I will convert this into Newton mm. Next I'll calculate T max, which is 1.2 times T mean. That is this value that I have obtained. When I multiply this value with 1.2, I get 42.971 into 10 raised to 6 Newton mm. Next, I'll start with the first criteria, that is strength criteria. The formula is T by J. T is T max is equal to tau max upon R. For calculating J, the formula is pi by 32, D outer raised to 4 minus D inner raised to 4, and for R I'm going to use DO by 2. So when I substitute here, therefore T max is 42.971 into 10 raised to 6 divided by J is pi by 32, DO raised to 4 minus DI raised to 4 is equal to tau max is given as 60 and this is DO by 2. Now I know DI is 3/8 into DO. So we can substitute, therefore 42.971 into 10 raised to 6 upon pi by 32 DO raised to 4 minus 3/8 DO this whole term raised to 4 is equal to 60 upon dO by 2. The whole equation is in terms of dO now. When I solve this, I get the value of dO as 154.962 mm. This you can approximate to 155 mm. So this is one answer that I obtained. Now DI is 3 by 8 times DO. So I get the value of DI as 58.125 mm. So this is another value that I want to find, DI and DO. Next I am going to use rigidity criteria for calculating the value of DI and DO. So let's write down. Second is my rigidity criteria. Rigidity criteria, as we have discussed, is also called as stiffness criteria. The formula is Tmax upon J is equal to G theta upon L. Now let's substitute directly over here. The value is 42.971 into 10 raised to 6. For J I have pi by 32. dO raised to 4 minus di raised to 4 is equal to, G value is given as 0.85 into 10 raised to 5. Theta is now 2 pi upon 180 and L was 4000. When you solve this, substitute di as 3 by 8 do, you will get the value of do as 156.645 mm. This can be approximated to 157 mm. This is one answer. And when I substitute di is 3 by 8 do, here if I substitute do, I will get the value of di as 58.875 mm. Now this can also be approximated to 59 mm. So I have found di and do using both the methods. Now I need to find out which value is safe for both the shafts. So for that I am going to substitute this value of di and do in this equation, and I'll check if di and do from the second criteria satisfies the first criteria, and then I'll substitute these two values in this equation and find out the value of theta. It should be less than the maximum value of theta given. If that satisfies this equation, then I would say that the first two values are safe. Now that we have to decide by the check method. I know do and di value. This is the first criteria, so I am using the values from the second criteria, that is these two values, 157 and 59. Now when I solve this, I have 42.971 into 10 raised to 6 upon pi by 32, 157 raised to 4 minus 59 raised to 4 is equal to tau max upon 157 by 2. When I solve this, I get the value of tau max as 57.702 Newton per mm square. This is less than given value of 60 Newton per mm square. So I can say that these values of diameter are safe. Now let me substitute the values of the first case, these two values, in this equation, second equation over here. So I'll write down T max upon J is equal to G theta upon L. DO is 155 mm and DI is 58 mm. Therefore 42.971 into 10 raised to 6 upon pi by 32, 155 raised to 4 minus 58 raised to 4 is equal to 0.85 into 10 raised to 5 Theta is what I'm trying to calculate and L is 4000. When I solve this, I get the value of theta as 0.03639. This is in radians. I will convert this into degree by multiplying with 180 upon pi. I get this value as 2.0855 degree, which is more than the value which is given, that is 2 degree. Hence, this value of diameter is not safe. Therefore, the chosen value will be and di is 59 mm. With this, I end the session. I hope you have understood this numerical. If you have any doubts, please write to me in the comment section. See you in the next session. Thank you.